These are the solutions to the first set of practice problems. So, number 1, there's an equilateral triangle. One circle is circumscribed, another is inscribed. Find the ratio of the radii that is greater than 1. So, if I just draw a circumscribed circle, that's what that is. And an inscribed circle, the radii go like this. And if we just take out this triangle, this is the smaller radius and this is the bigger radius. And because it's it's an equilateral triangle, this is 30 degrees, this is 60 degrees. So we know r over r is the same as 2. Number 2. Okay, it's just, you can pretty much ignore everything except for the triangle. This is 3, this is 6. They told you BED was 30 degrees. They give you these are both right angles, which means they're parallel. Cool. Find the length of AC. So they're saying find the length of that. If that's 30 degrees, this is 60 degrees, and just ignoring, the entire small triangle and just looking at the bigger one, you know this is a 30, 60, 90. If this is 9, and therefore this is 9 root 3. Well, number 3 was find this distance right here. So if you just draw the triangle again, this is 3, this is 6, this is 30 degrees, this is 60 degrees, meaning this right here is 3 root 3, and then you just use quadratic formula to get 6 squared plus 3 root 3 squared square rooted, which is square root 36 plus 27, which is 63, so 3 root 7. Number 4, tangent of theta is 1. What is EO? Okay, you're given a right triangle. This is theta, this is 5, this is x. And they're asking for EO. Okay, they're asking for this right here. If tangent theta is 1, this is also equal to opposite over adjacent, which is 5 over, let's call this y, 5 over y. And if that equals 1, then y equals 5. Number 5. This one is actually disputable, so there are 2 accepted answers. So they said the sine of s is 2 to the negative first. Sine of angle O is 3 to the negative first. So you can use law of sines here, where basically the side opposite the angle divided by the angle, well, the sine of the angle is constant in a triangle. So you could do x plus 7 over, this is a side, the angle opposite the side is s. So sine of angle s, which is 2 to the negative first, equals sine of angle O, well, the side divided by the side of angle O, is 7 over 3 to the negative first. Solving that, that's just x plus 7 over 1 half equals 7 over 1/3, which is 21. That's 21 halves minus 7, which is 7 halves. So you can get 7 halves, or you can say angle S is a 90-degree angle, and sine of 90 degrees is 1. Therefore, this is a flawed question. So either one is acceptable, and yeah. Number 6. Trapezoid IMS is not isosceles. Where's the angle of, okay, sorry, not angle, area. Let me just draw it out. IMS. So, for this type of question, they told you area of MES is 10 units squared. So for this type of question, area of a triangle is 1/2 base times height. So it's needing nothing except for the base and the height. So in this case, sorry, that's the ugliest brace I've ever drawn. The base is shared, and because this is a trapezoid, the height is shared, which means the base and the height both don't change, therefore triangle IES, ISE, same thing, is also equal to the area of MES, which is 10 units squared. Number 7, a flag. Jim sees that a shadow is 1 meter long, but he is 2 meters tall. The shadows of the flagpole is 10 meters. What is the height of the flagpole? So for these types of questions, they're similar triangles because they're both from the sun. So this angle is the same and this angle would be the same. So angle, angle, angle. And because the scale factor is 10, scale factor is 10 again, so 2 times 10 is 20 meters. Number 8. There was a confusing drawing, but that was literally only there to distract you, because never trust the diagrams that I give you. They said triangle EMO is similar to triangle PAM. They said EO was 3, PM is 5, MO is 6. Which, from here it's, what is X? Given AM is X. Okay. So with these types of questions, I like just writing it out like this and just EMO, PAM. So I'll do EMO over PAM, so the side lengths of EMO over side lengths of PAM. EMO is, EO is EO, so that correlates to PM. So EO over PM equals, and then you have MO over AM. So I think the curves kind of match. So EO is 3, PM is 5, MO is 6, AM is X. X equals 6 times 5/3, which is 10. Cool. Number 9. For these types of questions, they're just annoying to read. Nate drives 3 miles north, 10 miles east, 8 miles south, 20 miles west, 5 miles south, in that order. In that order literally makes 0 meaning. How far is Nate from his starting position? So in this case, just kind of cross them out. This is 5 miles south. That's 10 miles west. That's 10 miles south. So from his starting position, he goes 10 miles west and 10 miles south. So that would be a distance of 10 root 2. Miles, sorry, not meters. You could put that on a coordinate plane and you get the exact same answer. Number 10, these are circle questions. So this is X, this is 3, this is 4, this is 5. So a good thing to memorize is whoa. So the whole thing times the outside equals the whole thing times the outside. The whole thing is 9, the outside is 5, the whole thing is X plus 3, the outside is X. So I don't think this factors. X squared plus 3x minus 45 equals 0. So now you have to use quadratic formula, equals negative 3 plus b squared minus 4ac, 9 plus 4 times 45 over 2. And normally it would be negative b plus minus, but in this case it can't be a minus because side lengths can't be negative. So, well, these aren't side lengths, but lengths can't be negative. So simplifying this, you should get negative 3 plus square root 21, 3 root 21, sorry, over 2. Number 11. This is a theorem. So given tangents from a circle, if this is 5 and this is 5, basically tangents from a circle, well, tangents to a circle from the same point are equal. So y equals 5. Way you could solve this though is whoa. So 5 times 5 equals y times y. So y equals 5. Or you can just memorize this theorem. Cool. Number 12. This is just another whoa question. I did not mean to make that a secant. That's a tangent. I'm not good at drawing. That's 5, that's 4, and that is y. So whole thing times the outside equals y squared. So y equals 2 root 5. Number 13. This is product of chords. Basically, the two segments of the chord multiplied together are constant. So in this case, 7.5 times x equals 3 times 5, which is 15. Therefore, x equals 2. Number 14. This was a question that went like this. That's the center. That's 5. 10. That's 2. So first thing is use the whoa. So you get, whole thing times the outside equals that squared. So let's just call t because it's a tangent. And tangents are perpendicular to the radius connecting the points. So you get t is 2 root 6. And then they were asking for this length right here. Distance between B and circle A. So yeah, they're basically asking for not this entire length, but just this length. So if this is 2 root 6, you can use Pythagorean theorem to get 2 root 6 squared plus 5 squared. Square the entire thing. You get 24 plus 25 is 49, which is 7. But that's distance from point A to point B. Now if we're looking for the distance between point B to circle A, you get 7 minus the radius, because you need to subtract all of this, which would be 5. And that's your answer. And yeah, that's it for this practice problem set. Some good terms to know for this unit. That's a secant. Basically, the endpoints are not on the circle, whereas for a chord, the endpoints are on the circle. And then a radius and a diameter should be terms you're pretty familiar with. Goes through the center. And yeah, that's pretty much it. And then for tangents, they're perpendicular to the circle center's radii, radius. So yeah, those are some helpful terms to know for circles, and yeah, that's pretty much it. If there's any problems with this set, look in the description. I'll probably edit something into the description if I made a mistake.